Welcome to BioVivacious. BioVivacious, as you know, is a YouTube channel dedicated to clear fundamental concepts of biosciences. Today we are going to deal with gout. Gout is associated with nucleic acid metabolism. Gout was considered to be a disease that is prevalent among the kings and the rich people. So it is basically a genetic as well as an acquired disease. So what happens in gout is in the uric acid gets accumulated in the body. So the uric acid, let us first of all write the structure of uric acid in order to understand this topic. So uric acid So this is the structure of uric acid. Now what happens to uric acid is this is the metabolic end product of nucleic acid metabolism. Especially when purines degrade in our body, this will be ultimately converted to uric acid. So this is the structure of uric acid, and it will be constantly produced in our body. And the normal level is about up to less than 7 milligram percentage is the normal level of uric acid in serum. So on an average, every individual will be producing about 6 milligram of uric acid per 24 hours. So this is the general production of uric acid. Now what happens to this uric acid? Remember, this is slightly on the higher side in men than in women. Now what happens to this uric acid is in the pKa value, you can see that these are all get ionized. So here also there is an OH. So this can get ionized. Now if the pKa value of uric acid is, pKa of uric acid is 5.4. So what will happen to uric acid in blood pH? This will get ionized. So therefore, this is going to be O minus. It will get ionized in the blood pH. Now what happens in blood pH is, blood has a lot of sodium ions. So sodium will get bound to this. So therefore, this forms sodium, monosodium, urate crystals. Okay, it becomes monosodium urate crystals. Now what is the problem with the monosodium urate crystals? So the problem is this is not really soluble in blood. It is not really soluble. Since it is not really soluble, it has the tendency to get accumulated and it becomes a kind of a crystalline structure and gets accumulated in the joints and mostly in the extremities. Why in the extremities? Because we have seen that its solubility is very low. It is highly soluble at greater than 37 degrees Celsius centigrade. But you know that our extremities, the temperature can be lower than 37 degrees Celsius because it is getting exposed to the environment. As the temperature goes down, the solubility also decreases. So therefore, this will get accumulated as crystals in the joints, especially in the toe. That is a place, extremities, it gets accumulated. So when it gets accumulated, what happens to this? So our immune system will see this sodium urate crystals as a foreign body. So therefore, you have learned about phagocytosis. So phagocytosis begins and all the lysosomal enzymes are released, and the lysosomal enzymes will induce an inflammatory response. Inflammatory response, you know that pain, inflammation, high temperature. So these are all symptoms of inflammatory response. So resulting is severe pain associated with the gout. So this is the basic understanding of gout. So therefore now what we are going to do is we are going to understand how gout is formed. What are the reasons? And we will look at the gout purely from a biochemical perspective. Okay? So from a biochemical perspective, we can say that gout arises due to two reasons. One is called primary reasons. Primary reasons means it's directly involved. It has one-to-one relationship. That is primary reason. The second is something called secondary reasons. Secondary reasons means not directly involved, but via, it has some influence on precipitating gout. So let us look at what are the primary reasons for gout. So there are two main reasons, primary reasons. The first primary reason is in the activity of an enzyme known as PRPP synthetase enzyme. Okay, so PRPP synthetase enzyme. What is the problem with the PRPP synthetase? This is a mutant form. Remember, this enzyme is an X chromosome related enzyme. It's an X chromosome related enzyme. So it becomes a mutant. So mutant means this enzyme will not behave properly. It will not respond to feedback inhibition or allosteric modification. So that is the reason with the PRPP synthetase enzyme. So let us see what is the exact role played by PRPP synthetase. Now, what is the problem with the PRPP synthetase? So therefore, we need to understand primarily the synthetic pathway for purines. So very simply, as a flow chart, we will look at the synthetic pathway for purine, and we will focus only on those areas that we need to understand in order to grasp gout. So if you start with glucose 6-phosphate, you know that glucose 6-phosphate has got multiple fates. It can become glucose, it can enter into glycolytic pathway, and it can also enter into pentose phosphate pathway. What happens in pentose phosphate pathway? You will get a product called ribose 5-phosphate. Ribose 5-phosphate is the starting material for purine synthesis. So what happens to ribose 5-phosphate? Ribose 5-phosphate is acted upon by an enzyme called PRPP synthetase. And what else is required? An ATP is required. Pyrophosphate is taken from ATP, so you will have the remaining AMP. Now this pyrophosphate is added to ribose, so you will get PRPP. PRPP stands for phosphoribosal pyrophosphate. So this is catalyzed by an enzyme called PRPP synthetase, our enzyme. Now let us continue a little more in order to understand the mechanism. Now the PRPP is acted upon by the next enzyme, that is with the addition of a glutamine. Glutamine is added to PRPP and you will get a product called 5-phosphoribosylamine. 5-phosphoribosylamine is formed. Now here there is an enzyme. That enzyme is called glutamine PRPP amido transferase. Okay, PRPP glutamine amido transferase. That is the committing step of purine synthesis. So therefore this enzyme is also important. So let us understand what happens next. What happens next is this will be converted to inosine monophosphate. Okay, inosine monophosphate that result into GMP and AMP, and ultimately it will be converted to uric acid. Okay, so I am not elaborated this region. So therefore it is ultimately converted to uric acid. So this becomes the degradative portion pathway of nucleic acid. So this is a synthetic and the lower portion is the degradative pathway. There is an enzyme which is very crucial, and that enzyme is xanthine oxidase. We will come to xanthine oxidase a little later, but I want to have the perspective about this particular enzyme. We are talking about three enzymes, 1, 2 and 3. Now what is also important is a positive modifier of this enzyme is PRPP. PRPP becomes a positive modifier of amidotransferase enzyme. So remember that. Now having understood this pathway, let us see what is the problem with the PRPP synthetase. Now we have said that it is a mutant form. So what regulates this enzyme is GDP can regulate this enzyme, negatively inhibit. Okay, or ADP can regulate this enzyme. Inorganic phosphate also can regulate the activity of this enzyme. That is feedback inhibition. This is a mutant form. So therefore, if the enzyme is not behaving to feedback regulation by any of these molecules, the enzyme is not behaving. So therefore, the activity of the enzyme increases. Enzyme concentration is not increasing, but the activity of the enzyme. If the Vmax is going to be about 3 times more than what the normal Vmax is. So since the Vmax increases, what will happen? There is going to be overproduction of PRPP. If there is overproduction of PRPP, tell me what will happen? This will stimulate this particular enzyme, amidotransferase. It is a feed-forward stimulation. Example of a feed-forward stimulation. This will activate, it will produce a lot of inosine monophosphate and produce GMP and AMP. So you understand? And that will result into, there is overproduction, cannot be incorporated into nucleic acid, extra will be degraded to uric acid, and you have seen what happens to uric acid. It will precipitate in the formation of gout. This is one of the primary reasons for gout. If this is clear, let us go to understand the next reason for primary gout. So therefore, if the next reason is in deficiency of an enzyme, and the name of the enzyme is HGPRTase. This is deficient. Okay, what is the full form of HGPRTase? Hypoxanthine guanine phosphorybosyl transferase. What is the role of this enzyme? In the salvage pathway of nucleic acid. What is the salvage pathway means? It is to save hypoxanthine and guanine. So when these products are getting accumulated or produced in the cell, we want to salvage them. Okay? In order to salvage them, to this PRPP is added. And this will, with the help of this enzyme, you will get hypoxanthine will give inosine monophosphate, okay, and inosine monophosphate and PPI. What will happen to guanine? It will produce GMP and PPI. Okay, so this is what we call the salvage pathway. Now, if there is a deficiency of this enzyme, it will precipitate gout in 3 ways. The first way is here. This is the first mechanism. What happens here? This first mechanism. So these are not consumed. If these are not consumed, it will get accumulated. That will result into uric acid. You see how it is being formed. Okay? It becomes uric acid. Increase the concentration of uric acid. One way. Second, if PRPP is not consumed, what will happen? You should already say that it will stimulate which enzyme? Glutamine, PRPP, aminotransferase. If it is stimulating, what will happen? Increased production of uric acid and other nucleic acids will occur. You see how it is precipitating. And the third mechanism is by this. If these nucleotides are less, that means through salvage pathway, these nucleotides are not produced. When it is less, it will send a reverse information back to the cell saying that there is reduced level of GMP, start activating in the purine synthetic pathway. So in every way, by using three mechanisms, it will increase the production of uric acid and it will contribute towards formation of gout. These are the primary reasons for the formation of gout. Let us look at the secondary reasons. And as I have told you, the secondary reasons are not directly involved, but it is indirectly involved. In the secondary reasons, the first secondary reason is there is a deficiency of an enzyme known as glucose 6-phosphatase. So there is a deficiency of glucose 6-phosphatase. Remember, you have come across glucose 6-phosphatase when you were dealing with glycogen metabolism. Deficiency results into number one, the first type of glycogen storage diseases, Van Gogh's disease. So you know that this enzyme is required for making glucose available. So therefore, if this enzyme is not present, what will happen? If the precursor molecule, that is glucose 6-phosphate, will get accumulated. So glucose 6-phosphate, this enzyme acts, glucose is formed. So if this enzyme is deficient, glucose 6-phosphate gets accumulated. When there is plenty of glucose 6-phosphate, you are promoting glucose 6-phosphate to enter into PPP and formation of ribose 5-phosphate and nucleic acid. You see how it is indirectly affecting. And the second mechanism, that is an enzyme known as glutathione reductase. So what is the issue with the glutathione reductase enzyme? You know that glutathione reductase enzyme is responsible for production of NADP+. So if there is an increased activity of glutathione reductase enzyme, this will increase the production concentration of NADP+. Higher the concentration of NADP+, that will stimulate pentose phosphate pathway. And you know that in pentose phosphate pathway, 2 steps NADP+ is required. Step number 1 and step number 3. So PPP is stimulated. If the net result is increased production of ribose 5-phosphate, that will lead to increased nucleic acid synthesis, that will lead to increased uric acid. You see how this is contributing towards production of production of uric acid. There is a third reason for precipitating gout, that is nutritional aspect. So we began by saying that this was a disease associated with the kings and the rich people who eat a lot of food. Okay, overeating, associated with the overeating. So what happens with the overeating is, especially when we consume a lot of nucleic acid containing food, plenty of nucleic acid is consumed, and nucleic acid, it has to be degraded in the body. And this nucleic acid, when it is degraded, it will also get absorbed and it will contribute towards uric acid formation. Another problem is with the consumption of wine. So wine is normally gets contaminated with lead, Pb2+. So now this lead can inhibit the crucial enzyme in the purine metabolism. That is, the amido hydrolase is inhibited. If that enzyme is inhibited, one of the precursor molecule for that is glutamine, and glutamine is not consumed. Glutamine get precipitated, get accumulated in the joints, and glutamine is known to induce inflammatory response. You see various ways by which uric acid or gout is formed in the body. What is the solution forward? Let us look at the solution. So, the remedy for this is, the first remedy for this is, without saying, is goes that regulate food habits, regulate consumption of nucleic acid rich food, avoid alcohol from diet, okay, and this has to be regulated. There are many medicines available in the market to treat gout. I'm going to talk only about one such medicine, and that medicine is allopurinol. See, allopurinol is a structural analog of adenine. It's a structural analog. Let us draw the structure of allopurinol. Okay, hydrogen. Okay, so this is done. This is the structure of allopurinol. The structural variation has occurred. So this is carbon number, this is number 1, 2, 3, 4, 5, 6, 7. 7 nitrogen is shifted to the 8th place. That is a structural change has happened. Structural analog. So when we talk about allopurinol, we need to speak about two very famous scientists. See, when we learn things, we need to understand how the knowledge which we acquire can be useful in future. Two scientists, their names I am writing here, Gertrude Lillian and George Hitchings. Okay, Gertrude Lillian and George Hitchings, two very famous scientists. Lillian was born in, I think, 1918 and died in 1999. And Hitchings was born in 1905 or something, and he died in 1998. They have patented, because of their knowledge in nucleic acid, because of their knowledge in structure of nucleotides and in metabolic reactions, they have patented about 1300 medicines, and they are all based on the nucleic acid structure. And because they knew their metabolism well, they knew the mechanism of action of enzymes well, they knew how to manipulate the structure of a nucleotide and make suicide inhibitors. That is what they have done. They have discovered acyclovir, which is used as a R protease inhibitor. They have devised medicine for HIV. They have devised medicine for cancer and gout. Like that, 1300 patents they have based on these structures. Let us understand how exactly this mechanism operates. What is important is, remember in the beginning we spoke about an enzyme called xanthine oxidase. Now see, this xanthine oxidase is required for converting hypoxanthine to xanthine to uric acid. Okay, now xanthine oxidase requires molybdenum 6+ for activity. Okay, it requires molybdenum 6+ for activity. What happens in this case is, these names you should learn by heart, rubbing them. What happens in this case is, molybdenum which is existing and as molybdenum 4 plus, it will enter, it binds to this allopurinol. It binds to allopurinol and it binds so tightly. That's why I said it is, and this molybdenum is present in the active site of this enzyme. So this allopurinol binds to this. 6 plus is required for activity, and this substance will not allow molybdenum 4 plus to reoxidize into the 6 plus form. So therefore, no activity for the enzyme. Enzyme is inactive. This is one way by which allopurinol acts. So what happens if this enzyme is inhibited? This will get accumulated. Hypoxanthine get accumulated. Now, hypoxanthine is more soluble in water than uric acid. So therefore, it will be dissolved in water and it will be excreted through the kidneys. In our urine, it will be excreted. That is the mechanism. That is one of the mechanisms. There is also another mechanism by which allopurinol acts. So therefore, let us see what is that mechanism. So what happens is, it works with Hg-PRTase enzyme. So you know that in the Hg-PRTase enzyme, it will use PRPP. We have seen the salvage pathway earlier. If the PRPP is used and a nucleotide is formed in the salvage pathway. What allopurinol will do is, allopurinol can bind with this. Okay, allopurinol binds to this and it forms allopurinol ribonucleotide. So what happens with the allopurinol ribonucleotide? So PRPP is not available now. Inorganic phosphate. Okay, what happens now? Allopurinol ribonucleotide is an inhibitor of amido hydrolase. Okay, this is an inhibitor. So therefore, inhibitor of amido hydrolase. So therefore, purine synthesis cannot occur. And at the same time, by combining this, the concentration of PRPP decreases. If the concentration decreases, you know that it cannot stimulate nucleic acid synthesizing pathway. You see now how by using varieties of ways, this allopurinol is inhibiting uric acid synthesis. So this is only one of the medicines. There are other medicines that are used. So the whole idea was to give you a kind of a glimpse of how these drugs operate and how important it is to have a deep knowledge about the subject that you learn.